Welcome to a trigonometry proof/verification in which we will be confirming that the center of oscillation plus the amplitude of a trigonometric function is equal to the maximum value of that trigonometric function. Okay, so let's start off with what we know. All right, or what we think we know, rather. So we think we know that the center of oscillation plus the amplitude is equal to the max. And just for visuals, I've drawn a sine wave up here. So the center of oscillation is the middle point between the minimum and the maximum value, you could refer to it as. The amplitude is the distance between the center of oscillation and the maximum or minimum points, and the maximum is, of course, the largest y value of the function. Okay, so we're assuming that the center of oscillation plus the amplitude is equal to the maximum of the function. So sort of using that definition that I just gave you, we're going to substitute in the fact that the center of oscillation is equal to the average of the maximum and the minimum value of that function. Okay. And then similarly, we're going to substitute in the fact that the amplitude is equal to half the distance between the maximum and the minimum, right? So if the amplitude is the distance from the center of oscillation to the maximum or the minimum, then it needs to be half the differential between the maximum and the minimum value. So we could substitute in that amplitude is equal to maximum minus minimum over 2. And we're going to set this equal to the maximum value. Okay, now these two terms on the left-hand side have a common denominator of 2, so we could add the numerators. So when we add the numerators, we get max plus min minus min. So the minimums will cancel out and we'll have 2 maximums. We'll have 2 times the maximum value divided by 2 is equal to the max. I should be adding that we're supposed to be questioning this. So this isn't a given. We started off with something that we assumed was true, and now we've come to the conclusion that indeed this is true, because twice the maximum divided by 2 is equal to the maximum, which is to say that the maximum value is equal to the maximum value. So the left-hand side of the function turned out to equal the right-hand side of the function, and that is how we have confirmed that the center of oscillation plus the amplitude equals the maximum value of the function. And as you could probably see, a similar version of this proof could be used to determine that the center of oscillation minus the amplitude would then equal the minimum value. I won't do a video on that because I think it's kind of trivial given what I've just showed you. But anyways, drop a comment or a like on this video if it helped you out with your trig or your pre-calc maybe, and stay tuned for more videos. Thanks, guys.